Hi class, welcome to our last lesson on chapter 9. We're on 9.6. What we're doing in this lesson is we're solving rational equations. Solving means getting x all by itself, or isolate x. So that's going to be one thing that we're doing. With rational equations, it means that we're going to have a variable in the denominator. So you've already done something similar to this back in middle school. You might have seen something like this. 2/3, just an example, plus x over 4. That equals 17/12. And when you had to solve for x in this case, x is in the numerator, so that's why it's different from our today's notes. But when you did this back in middle school, what you had to do is you had to multiply by the greatest common denominator, or the GCF, and in this case it is 12. Your denominators are 3, 4, and 12, so the GCF is 12. And then you would take 12 and you would multiply it by all three of these terms, or you would distribute it. So you took 12 times 2/3. 12 over 3 is the same thing as 4. So now 4 times 2 is 8. You did the same thing here. You took 12, and then 12 over 4 is 3. So 3 times x is 3x. And then you took this 12 times 17/12. These 12s canceled, and you got 17. And then you simply solved it by subtracting 8. So 3x equals 9, and then you got x equals 3. After you got an answer of x equals 3, your middle school teacher might have told you you can check your work just by putting 3 back in for x again. So by putting 3 in there. So if you were to take your calculator and go 2/3 plus x over 4, which is now 3/4, you should get 17/12 if you did it correctly. And if we were to check our work, we would get the left side equaling the right side. So that's kind of an introductory into what we're going to be doing today. The only difference is that we have a variable in the denominator. So here for our first one, our variable x plus 2 is in the denominator. But we're still going to solve the exact same way. We're going to get our factors, 28, x plus 2, and 4. And we somehow have to get a GCF. So what number do all three of those go into? Because 4 goes into 28, you now basically have just two factors, 28 and x plus 2. So your GCF is going to be these two multiplied by each other, 28 times the quantity x plus 2. Once you multiply each individual term by 28 times x plus 2, the denominator disappears. So that's going to be our next step. So 9/28 times 28 times the quantity x plus 2. This 28 and 28 cancel. So now it's just 9 times the quantity x plus 2. On our next term, we're now taking 28 times the quantity x plus 2 and multiplying it by 3 over x plus 2. The x plus 2's cancel, so we just get 3 times 28. And then for our last one, the 28 and the 4, those reduce to 7 over 1. So now it is 3 times 7 times x plus 2. And now we do not have a denominator anymore. So now we're going to solve. First, let's distribute. So we have 9x plus 18 plus 3 times 28, which is 84. That equals, and this is basically 21, correct? So now we're going to distribute the 21 to get 21x plus 42. All right, let's combine like terms. I'm going to subtract 9x from the left to get it off onto the right. And then if you add up 18 plus 84, you get 102. That equals 12x plus 42. And then we'll subtract 42. So 60 equals 12x. And then we'll divide both sides by 12. So now we'll get our answer of x equals 5. Here's what I'm looking for. In class, I'm not going to require you, but if you wanted to, you could check your work on every single one of these. X equals 5. So if x equals 5, we can put 5 in there. And then we could take 9/28 plus 3 over 5 plus 2, which is 3 over 7. If we took 9/28 plus 3 sevenths, we would get an answer of 3/4. You can check your work with every single one of these. Now there's one more thing I have to say with each and every one of these problems, is that you can never get a denominator of 0. That's breaking math rules. So what happened if we got x to equal a -2? If x equals a -2, that would make this denominator 0, and you can never divide by 0. So x equals a -2 would be an extraneous solution if you somehow got that. So after you solve these, you need to go back to the original equation and make sure you are not dividing by 0. So we'll have one of those coming up in one of the next problems. Why don't you guys try number 2 on your own, pause the video, and let me see how you do, and then check your work with mine after you're done. So what you should have got for a common denominator, multiplying everything by 24 times the quantity, 3 minus x. 4, 3 minus x, and 24 all go into this greatest common denominator. 24 times the quantity, 3 minus x. So now we're going to cancel these 24s, and it's going to be 5 times the quantity, 3 minus x. Next term, 24 times the quantity 3 minus x times 2 over 3 minus x. These 3 minus x's cancel. So now we're left with a positive 2 times 24. And then our third term, the 24 and the 4 reduces to 6. So now it's 1 times 6 times 3 minus x. There goes our denominator. Now let's get rid of our parentheses by distributing. So we have 15 minus 5x plus 48. That equals 18 minus 6x. Let's clean up a little bit here on the left side by combining like terms. 15 and 48 make 63 minus 5x equals 18. 18 minus 6x. And then we are going to add 6x, and we're going to subtract 63. So we get a positive x equals 18 minus 63 is a negative 45. Once you've isolated x, you're all done. This is our answer. Go up top to make sure you're not dividing by 0. On this one, if you had 3 here, that would make it 0, but because we have a negative 45, that should be good. You could check your work if you would like to, but I do not require that. X equals a negative 45. This is your answer. Let's try number 3. On this one, we have to know what all of our factors are. Because this is a trinomial, let's factor this to find all of our factors. So this turns into x minus 2 times x minus 1. So our factors are x minus 1 here, x minus 2 here, and both of them there. So our least common multiple, or our common denominator, is going to be x minus 2 times x minus 1. It's just these two multiplied by each other. So now, taking this and multiplying it by all 3 terms, on the first one, x minus 1 and x minus 1 cancel, so you're just left with 4x times x minus 2. Now multiplying the next one, the x minus 2's cancel, so we have a negative 5x multiplied by x minus 1. And then for our third one, the x minus 2's cancel, and the x minus 1's cancel, so all we're left with is a 2 on the right side. Hopefully that makes sense. We are now going to distribute to get rid of our parentheses. So 4x times x is 4x squared. 4x times a negative 2 is a negative 8x. Negative 5x times x is a negative 5x squared. And a negative 5x times a negative 1 is a positive 5x. That equals 2. Okay, let's combine like terms. A negative, or 4x squared and a negative 5x squared make a negative 1x squared. And a negative 8x plus 5x is a negative 3x. That equals 2. Well, we can't solve for x the way we usually like to do it because we have an x squared term and an x term. So if we have this, we know that we're going to have to factor or else use the quadratic formula. So let's get our x squared positive. That would mean bringing it off to the right. Same thing with this one. So we have a 0 on the left. That equals a positive x squared, a positive 3x, and a positive 2. So now we're going to solve for x by factoring. X and x, and a positive 2 and a positive 1. These both equal 0. So if x plus 2 equals 0, and x plus 1 equals 0, x equals a negative 2, and x equals a negative 1. We have two answers for this one. Make sure that they do not make extraneous solutions. I know that x cannot equal a positive 1, but I didn't get that. I got a negative 1, so that is a good solution. And I know that x cannot equal a positive 2, which I didn't get positive 2. We got negative 2, correct? So both of these solutions work. If you wanted to check your answer, you certainly could. I recommend that you do that on a test. I think it's a great idea. But these two, both of them are your answers. All right, last one, number 4. This one, r, has a denominator of 1. So if you look at your GCF, this is r minus 1 times r plus 1. So your factors are 1, r minus 1, r plus 1, and r plus 1. So your GCF is going to be r minus 1 and r plus 1 together. R minus 1 times r plus 1. That's what you're going to multiply by all three of these. So with that, this is multiplied by r over 1. So there's nothing that cancels with the bottom. So you just have r times the quantity, r minus 1 times r plus 1. Second one, you have a cancellation here and a cancellation here. So you're just left with r squared minus 5. And then for our third term, which is the term that's on the right side of our equation, the r plus 1's cancel, but the r minus 1 stays. So you have r squared plus an r plus 2 times the quantity r minus 1. Alright, your denominator is gone, but you still have quite a mess up here. So let's clean things up a little bit. First of all, if we FOIL this, we're right back to r squared minus 1, correct? So I'm just going to FOIL this, and now we have r squared minus 1. Now we're going to take r and distribute it. So we have r cubed minus an r plus r squared minus 5. Now we're going to have a trinomial times a binomial. So I'm going to make sure that this term is multiplied by these two. So r squared times r is r cubed. R squared times a negative 1 is a negative r squared. And then I'm going to make sure that our middle term is multiplied by both of these two. So r times r is r squared, and r times a negative 1 is a negative r. And then I'm going to have this 2 multiplied by both r and minus 1. So a positive 2r and a negative 2. Whew! Okay, all our parentheses are gone. So now we're going to combine like terms. We have r cubed on the left. We have positive r squared, so I guess there's no cleaning up on the left, is there? Minus an r and a minus 5. On the right side, we have an r cubed. A negative r squared and a positive r squared make 0 r squared, so we don't even have to write that down. And then a negative r plus 2r is a positive r minus 2. Okay, if we subtract r cubed from this side to get it over here, well, now they disappear, so we don't have any more r cubes anymore. If we subtract an r, now we have r squared on the left and a negative 2r. And then if we add 2 here, we get a negative 3. And that equals 0. Once again, we have a squared term with r with a constant. So when you have something that looks like this, more often than not, it can be factored. So we're going to make r minus 3 and a positive 1. And then we're going to set both of these factors equal to 0. So x minus 3 equals 0. R plus 1 equals 0. So r equals a positive 3. And r equals a negative 1. Those are your two answers. You could always check your work, but make sure you go back to see if you make a denominator equal to 0. So if 3 is in our denominator, works here, works here, works here. So 3 is one of our answers. The other one is a negative 1. If you put a negative 1 in, oh, what happens if you put a negative 1 right here? What's a negative 1 plus 1? We get 0, and you can never divide by 0. So our solution of r equals a negative 1 is extraneous. It does not work. So make sure that you cross that off on your chapter test. You cannot have extraneous solutions. So we only have one answer of r equals 3. So we have one Excel math objective on that, and then there's just 2 more questions on a worksheet that I want you to do to get a little bit more practice as well. So be sure to let me know if you have any questions with that. That is the last lesson of the chapter. So after this lesson, make sure you do a good job on the review, take the Excel math test, and then we'll take our Chapter 9 test.